So we have a test coming up and it's for geometry, similarity, similar triangles. So we're going to use this to do these particular questions. So first off, we have this particular type of question that we're going to be looking at where we have this side right here, and we have this one and we're looking for x. So we have to do this by several different ways. So number one, using similar triangles, and we need to make sure that these are similar. So right here we have this angle. All right, so let's see, they have that one in common between these two triangles. So this is 23 and 34, 29. And then the bigger triangle, I'm not going to draw that very well. And this is going to be 46 because we take 23 plus 23, that gives us 46 right here. And then this one is 68. So now we're looking for this particular size. So now, first off, before we even start, they're going to have to get our common ratio. So starting off with this right here, common ratio is going to be between these two sides, or it could be this one or this one. Now it looks like everything is proportional, so we can go ahead and check if they need to fulfill that rule of side angle side proportionality. So if we take 23 divided by 46 and see if that's equal to 34 divided by 68. If we reduce these come out to be 1/2 equal to 1/2. So the common ratio is 1/2 between these two triangles. So we have proportionality based off of side angle side proportionality. So we have 1/2 equal to, since we took the 23, we're going to take 29 from here, 29 divided by x. Then cross multiply and divide, of course, if we need to. So x times 1 is going to be x, and 2 times 29, well, let's just do that really quick. 2 times 29, that gives us 58. So that's our answer, 58. So let's go ahead and move on with a few other things. Here's another picture. Now, this is sort of based off of midsegments. Midsegments, we know that this point and this point are midpoints, and that the height of the tree is what we call a midsegment. So the midsegment is always half of whatever the parallel side is going to be to it. So we're going to have this basic x equal to 160 divided by 2. So that's 80 equal to x. That's it. Pretty easy. Now, state whether or not the triangles are similar, support your answer. So first off, we only have angles here. So remember, the similarity statements are side, 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 angle, side, or angle, angle similarity. Now, in order for us to have angle, angle similarity, we need two angles in order to mark this as similar triangles. Two angles that are the same. So we have one angle in 35, and we don't have any other ones. So we suspect that this might be 70, the same as over here, but we're given 75 over here. So just remember, 35 plus 75 plus angle C is equal to 180. So we're going to add 35 and 75. So 35 and 75, we get a 1. Let's see, that's going to be 110 plus whatever the measurement of angle C is. Subtract 110. That gives us 70. So that means that this one's 70. And so we have angle, angle similarity. So because we have two angles off of two triangles that are congruent, then we have angle, angle similarity. Here's another one. Now we can either do this by the sides or by side angle side. So we're going to just check, since we have all the sides here, we're going to make some, how do you say, some assumptions. We have 6 is the shortest side on this triangle. 8 is the shortest side on this triangle. The next side in their size succession would be this side 8 and this side 11. And then we have 12 and 11. So then we just match up our similarities. Okay, so we have 6 divided by 8 because that comes from this angle, this triangle, and this triangle. See if that's equal to. Now, the next side in succession is going to be this one and this one. So 11 divided by 12. And remember, these all have to be proportional. Then let's see if that's equal to 8 divided by 11. Or 8 divided by, let's see, make sure that I have everything. I think I made one slight mistake, guys. Don't know my numbers. All right, so let's see. Let's do this one more time, just to make sure that they are correct. So 11 does correspond to 8, and 12 does correspond to 11, so yes. Let's go ahead and check that real quick. Okay, so 6 and 8, those correspond. And then we have 8 and 11, so that corresponds. And then finally, 11 and 12. And of course, nothing here is going to simplify down any further except for maybe this one, which is down to, let me see, they have a 2 in common and a 3, so that goes in simple down to 3 over 4, because that has 2 and 4. 8 and 11 cannot simplify, and 11 over 12 cannot simplify further. So therefore, these are not similar. If they had been similar, they would have been similar by side, 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 but that's not similar. Okay, so now we have this particular problem. So if you look at the length for x to s, that's 24 units. I'm also going to do the same thing from x to b, which is going to be 32 units. Now, we're going to check if we have similar figures. So let's see. According to side, angle, side, similarity. We can also do this by side, 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 but we're going to just check this one first, since they have an angle in common. So 8 divided by 32, see if that's equal to 6 divided by 24. So 8 divided by 32 and 6 divided by 24. And they both simplify to 1/4. So they are similar according to side, angle, side similarity. So yes, by side, angle, side similarity, or let's check for side, side, side similarity. So 12 divided by 48, and that definitely simplifies to 1/4 also, or side, side, side similarity. Okay, let's check this one. So let's see, we have this angle in common. We have this side and this side, which look like to be corresponding. So we have a 3 to 6, and this is 19 to 57. So we're going to go ahead and check that. This one's going to end up being 1/2. So let's see, 3 divided by 6. So that's 1/2. And 19 divided by, I think that was 57. Yeah. Yeah, 57. That 7 didn't look too good. 1/3. And so because these right here are not equal, they're not similar. We almost had it by side, angle, side similarity, but on this particular one, no. It had a falling out. So now we have this particular one. We're doing this by side, angle, side again. So we're going to check 3 over 6. See if that's equal to 19 over 38. So this is 1/2. And 19 divided by 38. 1/2. So this one is 1/2, 1/2. So yes, by side, angle, side similarity, and there's no other types of similarity here. So we have this particular example. We have this side, this angle, and this angle right here. So if we have angle, angle, this should be similar by angle, angle, similarity. So we're going to do this by the similarity parts. So the total right here is 15. So we have 9 to 15 equal to 3 to x, then cross multiply and divide. So that's going to be x equal to 45 divided by 9, which is equal to 5. So x is equal to 5. And that's it. While you're going ahead and solving this. All right, let's go ahead and check a few more. So judging by this information, we have this angle in common between these two triangles. And then we have this angle and this angle, both corresponding angles, which are both equal to each other. So that means that we have angle, angle similarity again. So when we set this up, we can set this up with these two things right here. So we have a 5 to 7 common ratio. That's equal to 8 over x. Then we cross multiply and divide and solve for x. So we get 5x is equal to 7 times 8, 56. And that's not divisible by 5, so it's just going to stay like this. So our x is equal to 56 divided by 5. And that's it. That's the only answer that we have. Okay. Now, just taking a look at this picture, they're asking what is the similarity between these two? How can we say that these two are similar if we can? So we have this angle in common. So remember, we have side, side, side similarity, side, angle, side similarity, and also angle, angle similarity. So let's see, we only have one pair of angles between the two triangles, so we can't use angle, angle. We don't have a third side, so we don't know about anything about this side and this side. So we can't say that those two sides are congruent or proportional. So this is not it. So the only one that we can use, we have one side that is reflexive because they share BD. So we can say BD is congruent to BD. And this is what we call a congruency statement, but this is still similarity because there's similarity with a common ratio of 1 to 1. So this is side, angle, side similarity. So that's your answer. Side, angle, side similarity. All right. So good luck on the test today. We'll go ahead and work on that.